So that is how the software developed during the past 70 years. And today we are going to talk about the programs and the programming. So as we said, what is the program? The program is equal software, right? A program equal a software, equal a list of instruction or a series of instruction, okay, for the computer. And what's its purpose? The purpose is that to accomplish the task. Okay, accomplish the task. What kind of task? The task is to process some data into some information. Okay. And the task is specific task you will defined by the human beings or by the programs. And so the program is, we can say it is also a set of statements, right? No matter what kind of programming language we use, it's a lot of statements. And the statements are used in some specific programming languages, in some specific rules. We define a lot of programming rules, and we use such kind of programming language and follow the rules, and we list a lot of statements so that a program can be accomplished. And the purpose is to accomplish some task, processing the data into the information. So we listed here like C++, like Java, like Visual Basic are some frequently used programming language. And in fact, the programs can also be pre-written or packaged before the computer was used, right? Like some operating system or some OTT softwares. It can also be custom made, right? You can design your own programs. The computer is programmable. We said in our previous class. So it can also be custom made. So when we do the programming, the program is a verb, is a nerve. But programming is a verb, right? When we do the programming, or we say that when we develop a software, in fact, or actually, it is a problem-solving procedure. It is also to solve some problems like our human beings had, but we need to define it in very, very detail in one step by one step with the instructions. So it is a problem-solving procedure. So we need to list a lot of instructions for the computer to follow so that the data can be processed. Okay, so we consider the problems and we use some we very familiar with some problem solving methods, and then it came up to be a list of instructions for the computer to follow. Because each instruction can only accomplish a very simple task, so we need a list of instructions to accomplish some complex tasks. And then we can follow a 6-step process for the software development. It is also known as the system development life cycle. Okay, if we develop some large-scale software, it may obey the rule of the system development life cycle. So as we have stated in the previous, a program is constructed by an algorithm and the data structure. The algorithm is the methods for solving the problems, while the data structure is how we store the information associated with the problem, right? And how we process such kind of data. So this is data structure is how we store and construct the data, while the algorithm is how we solve the problem with a lot of instructions. So the program is with the problem and go hand in hand with the algorithm. Okay, so since in fact most of you are, maybe not all of you, maybe most of you have not been China yet. So I in fact I showed here two very famous Chinese food or very famous Beijing food. Okay, first is a Beijing roast duck, and second is a Chinese Mongolian hot pot. Because in Beijing the goat meat is very delicious, very fresh. So these two are very famous Beijing's food. And in the future, if you really started in our campus, I hope you have the opportunity to test all these delicious food. But I listed them here because I'd like to say that the algorithm, when we create an algorithm to accomplish it or to solve any tasks, it is something like when you to cook some food. When you to cook some food, you need to divide your task into very small pieces, and you need list them one step by one step. You need all the food, right? You need to buy the original material for the food. That is, we need to prepare the data for the program. So before you cook any food, you need to consider what data you need, what material you are needed for accomplishing this cooking. So in the programming, it is similar. Before you do the program, you need to consider what kind of data are necessary in this task during your processing. So this is the first thing you need to consider, okay, the material, which is equal to data. And then the second thing is that as if you have already bought all the materials you needed, that is, we have already prepared all the data we needed for the programming, then you would like to thinking how to cook your meat or cook your food, right? So you may have step 1, step 2, step 3, one step by one step to put which one first and then which one in the following, and with how much with how many the small materials for the improvement. This is quite similar for the programming, as if the data has been prepared. Then you should to prepare to consider how to accomplish your task, how to solve your problem, and you need to list them one step by one step. For which data you do what kind of process, and then put such kind of data to what position, and then to do what kind of process with what kind of data, so that all the tasks can be accomplished. So you need to divide your big problem into many small pieces, and then you need to list all the procedures in this algorithm one step by one step. So it is quite similar. And also one more important thing is that when you divide these tasks into small pieces, one important thing is that you need to thinking in the computer or computing viewpoint. That is, in our human being, our head, our neurals are not exactly like the computer. As we said, I think our human being process the signals or the data or the information in our brain, in our brain. We are processing the analog signal, right? We processing such kind of analog information in the real world by using our billions of the neurons. But in the computer, in fact, it accomplishes tasks by using the digital computing, right? It digitalized the analog world into digitalize. It use some discretization approach to digital them. So first, the difference is that the computer process digital signals, and the second difference is that the computer in our human beings head, we may think some tasks as quite simple and we accomplish them directly. We do not. In fact, in many situations, we do not need to understand each step for accomplish any task, each step by each step. In fact, we can process some complex tasks in our computer directly. But for the computer, as we have said in the previous class for the instructions, each instruction can only process a very simple task. Okay, so it cannot process any complex task directly in one step. So we need thinking in the computer way. We need to break all this task information into very simple steps, one step by calling these instructions. So we need to know what instructions the computer can do, and we need to know how to divide our complex tasks into one piece with one piece into this very simple instruction viewpoint. So that is, we say, thinking in the computing way. Okay, thinking in the computing way. The computing thinking is quite different from our human being thinking viewpoint. And when we when we consider in the computing thinking, we're always thinking about two things. First is the data, what data you are processing, and what process you need to apply to your data. And the second is the instructions. Okay, very simple task, one step by one step, make it very clear in the computing viewpoint. So that's the two aspects I'd like to emphasize for the when you do the programming. Okay, what you need to always remember in your mind, the main difference, the key concept that for the programming, and the main difference between our human beings thinking. And then if you remember all these principles, underlying principles in your mind, and then you learn some programming language grammars, you learn some rules, how to follow these rules to accomplish such kind of task, then it would be much easier for all of you to learn the programming. Of course, when you learn any programming language, that you would have to learn a lot of grammar. You would have to learn a lot of the rules you need to follow, obey. And you need to know, like we have several data structures, that how we constructed such kind of data we need to process, maybe in the array viewpoint, or in the variable viewpoint, or in we constructed them like we use some pointer, something like that. Anyway, the most important thing is to remember the computing thinking in your mind. So when we do the cooking, as I listed, though these are Chinese, if you can read Chinese, you can read this comic. If you cannot read Chinese, it is also okay. That is just a teacher tell a student that what is an algorithm, and the student think, oh, it seems very difficult, right? And to solve some problems that seems very difficult. Then in fact, the teacher said, in fact, it is quite similar, like to do a cooking, to divide those things into several processes and follow these processes, then you can accomplish your task finally. What is the problem has been solved.